Now, if we look at the graph of e to the power of x, we may recall that an exponential looks something like that. So that's e to the power of x. If you reflect this graph along the line y equals x, you're going to get a graph that looks sort of like this. This is a log graph. In this case, it's log to the base e, x. Now, if we look at the domain of our log graph, well, x must be greater than 0. So for this rule here, we're going to assume that x is always greater than 0. Now, in NCEA Level 2, you came across logs for the first time. And for any question that just used log x, including the log button on your calculator, this was defined as log to the base 10x. In NCEA Level 3, we are only going to use log to the base e, because the rule for e to the power of x only worked for e to the power of x, as it was defined for that. So log to the base ex in your calculator is written as ln x, and it's ln because e to the power of x is considered in maths to be a natural growth curve, and so opposite of that is a log, or the natural log, or ln. You might get questions written as either ln x, which is often called ln x, or log base ex. They are the same thing. Now for a rule. If you have y equals ln x, the derivative is defined as 1 over x. And when we get further into this topic, I'll show you why that's the case. Now, of course, it's not going to be as simple as this. We're going to have to apply the chain rule as we have in other questions. So say we had function of x equals ln 2x. Well, f dash x equals, what we're going to do is do 1 over 2x, and then we're going to multiply by the derivative of 2x, which is timesing by 2. That actually gives us 1 over x, which is an interesting result. So that's saying that the function ln 2x has the same gradient curve as the function ln x. Now the reason for this is that we should know our log rules. There are 3 key log rules. The one for this one is log AB equals log A plus log B. So we could rewrite this function. Instead of ln 2x, it could be ln 2 plus ln x. Ln 2 is just a constant, so when that differentiates, it gets 0. And ln x will differentiate to 1 over x. The other log rules you should know are log A over B equals log A minus log B. And if you have log x to the power of n, we can bring the n in front to have n log x. Now, all these log rules are defined for any base, including base e. Say we had number 2, y equals 3 ln 2x squared minus 4. Same as before, I'm going to start actually by just rewriting the 3 over here. So times by 1 over the brackets, 2x squared minus 4, and then multiplying by the differentiation of that bracket, 4x. To simplify this, everything that is on the top, stays on the top, so that's 3, 1, and 4x gives us 12x over 2x squared minus 4. And all of these factors, and all of these numbers have a common factor of 2, so we could divide by 2 to get 6x over x squared minus 2. For some questions, a use of a log laws, one of those three mentioned before, will simplify the problem. So I'm going to start by looking at y equals ln x squared. I'm going to do this two ways. Firstly, we could just use our log rule. 1 over x squared times by 2x, which simplifies to 2 over x. Easy enough. You could also do this question by rewriting this as y equals 2 ln x. Bring that power in front. Then when we differentiate, we get 2 times 1 over x, or 2 over x. Number 4, y equals ln 3x to the power 3. Now this is not the same application as this rule here, because the 3 is applied to the whole function, not just the 3x. So we can't use that rule. Instead, this is the composite function, so we'll differentiate it with our composite function rules, which is just the chain rule, by bringing the 3 in front, rewriting the inside function and reducing the power by 1, then multiplying by the derivative of ln 3x, which is 1 over 3x, times by the derivative of 3x, which is timesing by 3. And it can be simplified. 3's cancel, giving us 3 ln 3x squared all over x. Finally, fx equals ln x over 2x plus 1. Looks complicated, but if we apply the dividing rule, which says that this is ln x minus ln 2x plus 1. Now, I've put the 2x plus 1 in brackets because otherwise it will look like ln of 2x and then plus 1. Don't necessarily need the x in brackets for the ln x because it's pretty clearly defined, but you're allowed brackets there if you want. This differentiates to, ln x differentiates to 1 over x minus 1 over 2x plus 1, and times by the derivative of the denominator gives us timesing by 2, gives us 1 over x minus 2 over 2x plus 1.